Hello. Today we're going to be looking at transformations. It's a shape topic. Transformations is about changing where a shape is or what a shape looks like when it's drawn on a piece of paper. And there are four types of transformations that can happen. They are the four. You can reflect a shape so it looks like it's been drawn in a mirror. You can rotate a shape, spin it round. You can enlarge a shape, which can strangely also mean making it smaller. And you can translate a shape, and that just means not changing the shape in any way at all, but just moving it from one place to another. Sometimes you can have a combination of them. You can reflect it and enlarge it, or you can translate it and rotate it. But today we're going to start with a fairly straightforward view of looking at reflections and rotations. And we're going to talk about what you're expected to be able to do to draw one, and what you're expected to do when you're asked to describe one. So let's take a look. We're going to do a reflection to begin with. We've got a shape there, and we've got two axes. We've got the x-axis going across, as it always is, because x is across. I'll always try and remember it that way. And the y-axis going up and down. If we're going to reflect a shape, we're going to treat something as a mirror, and this time I'm going to treat the y-axis there as a mirror line. So imagining that we put a mirror right there, and we're going to draw what you'd be able to see through the mirror. And it's really straightforward. All we need to do is we need to see how far away the shape begins from the mirror line. It's 1 square away on this, so we're going to be starting it 1 square away there. Put a little dot to help you start. And from that point onwards, it's going to be just reverse the shape. So the first bit is a line going straight up and down, like that. I'm going to go round from the bottom. So down here we had a line going away from the mirror line, so it's going to go away from the mirror line. Then it went up, and then away from the mirror line by 2 squares. Then it went up by 1, 2, 3 squares. 1, 2, 3. And then it came towards the mirror line by 1 square. Down by 1 square. And then along there towards the mirror line by 2 squares to join up. And we've got a reflection, okay, just as it would look in a mirror. That's completed. If we were asked to reflect that shape in the y-axis, then that's what we have to do. If you were given this picture in an exam already done, and it said describe the transformation that maps shape A onto shape B, if they gave them those letters, then what you would have to do to get 2 marks is you would have to say it's a reflection, so describe what the transformation is. It's not an enlargement, it's not a rotation, it's a reflection in the y-axis. Because for your second mark, you're going to tell them where it's reflected, because of course it could be reflected anywhere, couldn't it? It could be reflected over here, it could be reflected by some random line somewhere else. So first of all you're saying it's a reflection, and then you're saying how is it reflected. If we'd have wanted to reflect it in the x-axis, then of course we would have used this as our mirror line, 1, 2, 1, 2, and we would have drawn a reflection starting there. Okay, this line goes along there, then it goes away from the mirror line by 1, across by 2, away by 3, back in by 1, and then towards the mirror line by 1, over there by 2, and then joins back up again. And now this time, if I cover that one up, we've got a reflection in the x-axis. Okay, so that's what a basic reflection looks like. If it was to be a little bit harder, they might ask you to do this. Reflect it in the line y equals x. You need to look at an algebra video that we do to understand why this is y equals x, but just as a rough guide, when y is 1, x is 1 in that corner. When y is 2, x is 2. y is 3, x is 3. So y is always the same as x. Now, very often when you're doing a diagonal line reflection, I think it's quite easy to turn it so that that diagonal line looks as though it's vertical or horizontal. If you take a look at where to start, because your starting point is always the really important bit, get close to the line. Can you see here that there is a square? There's a square available there. So we need, over on this side, we need that square to be available here. And we've kind of covered two bits of that square, haven't we? These two lines here, I've just thickened up, match up to these two lines here. Now after that, it shouldn't be too hard to do, because moving away from the mirror line by 2 squares goes there. Moving away from the mirror line by 2 squares goes here. And then it really just turns itself into the rest of a square. And it's a reflection there in the line y equals x. Again, you notice that we get 2 marks for it. One for saying it's a reflection. Write it down, I'll turn it back the correct way now. 1 mark for saying it's a reflection, and another mark to say what it is. You could call that the line x equals y as well if you wanted, because if they're equal, they're the same thing, doesn't matter which way around you say it. But I do think that if you're going to do a diagonal line, turn it so that this is looking like a vertical or a horizontal line, and it makes things much, much easier. Makes it easier to spot. And get your starting point right. Spend time looking at the starting point, because after that you can fill everything else around it. So a reflection then, that is just basically a mirror, a mirrored version of it, and you're going to say it's a reflection if you have to describe it, and where it's reflected. Rotation next. Rotation means spinning it round. Okay, and the shape is going to look like any of those shapes that it might have looked like as I was just spinning this around. What I'm going to do is I'm going to, first of all, pick a point to rotate it from. And I put a big dot there. And that in here is called the origin. That's like 0, 0 if this was an axis with 1, 2, 3, 4, 5, -1, -2, -3 and so on. That'd be 0, 0, and it's called the origin, the centre. And I'm going to rotate this 90 degrees around the origin. Okay, so rotating it 90 degrees means that my shape is going to look like that, because I've turned it 90 degrees. So we're looking for something that looks like that. So long rather than tall. Where do we begin? Well, on this origin part, let's take a look at it. We went 1 along and 2 up. So if I'm going to rotate it around there, I need to be able to kind of think, where would that go if it was going to be turned 90 degrees, and it's crossed only 1 square there but 2 squares in height. So it's going to do the same kind of thing here, and it's going to be 2 squares along there. Can you see that the little dots that I've drawn form a right angle? And that helps us to work out where to go. Now that corner is this corner, and everything else has got to look like this. So that line was 3 squares, 1, 2, 3. This line was 2 squares, 1, 2. And then let's complete the drawing of the shape. It came down there, it came along there, and it did that. And that's been rotated. Now, we could get 3 marks here. If it asks you to describe it, it's a rotation. How much is it rotated? 90 degrees. And what's the centre of the rotation? Where was it spun around? Where was the place that, if we'd have stuck a drawing pin in and spun it, where is that place where the drawing pin would be. 90 degrees about the origin. Or, if we wanted to say, about 0, 0 as coordinates. So we've rotated, we've spun it round. That little thing there is very, very important. If we wanted to rotate it 180 degrees, we would have looked at this and said, okay, so it's crossing 1 space in that direction, 2 in this direction. So continuing down, it would have started there. That's 180 degrees, it's a straight line, and then we'd have got our shape spun round again. Not going to do it this time because you've seen it happen already now. So that's reflection and rotation. Now there is another video for enlargement because that can get quite complicated in certain places. So take a look at that if you want to do enlargement, but failing that, take a look at the books about reflection and rotation to make sure you fully understand how to start things off. And always remember that spending time to get your starting point for each shape is the most valuable thing. Once you've got that right, everything else is much, much easier to do. If you get it wrong, you're in a mess immediately, aren't you? I hope that's been useful. Thank you for watching Maths is Not a Mystery, and see you again soon. Bye bye.